All right, now we're going to talk about the geometric sequence where we're multiplying by the same number over and over again. So there's two formulas for this. The recursive formula is the same. We say the first term is equal to something. We have to say what the first term is. And then we multiply by the same number over and over again, and that number is r, which is called the common ratio. So then we do an would be the r times the term from before, which is an minus 1, the previous term. Now, explicitly, we can jump anywhere we want to in the sequence. So an, first term a1, and the common ratio is r times n minus 1. Because you don't multiply by r by the first term to get the second term. You got to multiply by r to the first term to get the second term. So you got to back up one space and make it n minus 1. So these are the two formulas for this section. Okay, so here are the examples. Example 1, we're going to write the two formulas out. So recursive, oops. So the recursive formula is a1 is equal to 1. So you say what the first term is. Now the common ratio here is multiplying by negative 6. So a1 or an would be negative 6 times the previous term. Done. The explicit formula is first term, which is 1, and then negative 6 is your common ratio, and then n minus 1, and that jumps you to anywhere you want to go into the down the list, the sequence. Geometric mean, we add two numbers together and divide to get the arithmetic mean. Well, we kind of do the same kind of thing. We're going to do two operations, but we're going to multiply two numbers together and then take the square root. So it's kind of analogous with the other one. So that'd be 1600. Square root of 1600 is 40. So 40 fits in here. But now it should make sense that this is the answer because it should work out how it jumps. So if we go from here to here, right, it's multiplied times 2, and then from there to there, it's also multiplied times 2. So it does work. The common ratio is 2. So 40 is the missing number. But how did I get it? I multiplied and then took the square root. Okay, now we're going to find two missing terms here. So from here to here, we're going to multiply by r, kind of like how we did the other one. Multiply by r, multiply by r. So I'm multiplying by 3 r's. So it's 2 is my starting point. R multiplied together 3 times is r cubed, and that equals 128. So divide by 2. R cubed is equal to 64. And I can take the cube root. R is equal to 4. So the common ratio is 4. So multiply by 4. And I get 8, multiply by 4, I get 32, and then multiply by 4, I get 128. So it works. So I made a little formula to figure out, a little algebra equation to figure out what was missing there. Okay, the last example is kind of an exponential decay problem. We have a $60 item, we're discounting at 30% a week. For 5 weeks, and we want to know what the sale is after the 5th week of the sale. So R is not 30. R is equal to 70% or 0.7 because you're throwing away 30%, but you're keeping the 70%. So it's going to be $60, and we're going to multiply it by 0.7. Now, if you multiply it by 0.71 times, that'd be the sale price after 1 week. We want to do it after 5 weeks, so we're going to do to the 5th power. And the answer for that's a calculator problem, so I'll get my calculator over here. So 60 times by 0.07, whoops, 0.7, not 0.07, to the power of 5, 1008. Okay, so it's 1008. So that would be the price after 5 weeks of the sale. So the formulas here for the geometric is here and there, And instead of finding D, we're finding R, which is the common ratio.